So we are looking today at just one example using the law of cosines. And remember that as we talked about law of sines in the past, law of sines was made for situations where triangles are not right triangles. Okay? So we are going to be looking at situations where they are not right triangles once again. Okay, now we know that we use the law of sines in any situation where we are given an angle and the side opposite. If I know an angle and the side across from it, I want to use law of sines. It's the most beautiful thing ever. So law of cosines is designed for situations where we do not have that information. We do not know an angle with the side opposite it, which means that you're going to use law of cosines in situations when we have side angle side and side side side, when you don't know an angle and the side across from it. Now, law of cosines, hopefully we remember that from geometry last year. There are really several variations of it. If I want my little a squared, it is equal to the other two sides squared, so b squared plus c squared, minus 2 times my other two sides, which are b and c, times the cosine of the angle that matches the little side on the other side, which is the cosine of angle A. All right? So if I'm looking for little b squared, it's equal to my other two sides squared, a squared plus c squared, minus 2 multiplied by my other two sides, a times c, times the cosine of my angle that matches the side I'm looking for, which is big B. And once again, if I'm looking for little c squared, I'm looking my other two sides squared, so a squared plus b squared, minus 2 multiplied by my other two sides, a times b, times the cosine of the angle that matches the side on the other side, so the cosine of angle C. Hopefully this brings back fond memories, law of cosines. Okay, so we're going to look at one example this morning. Solve triangle ABC. All right, so triangle ABC, little a across from angle A, little b across from angle B, little c across from angle C. All right, the information that you are given, yes, we've done this last year many, many times. Yep, shouldn't really be anything new to you. The information that I'm given, angle B is 81 degrees, little a is 22, and little c is 19. So notice that we have a situation where it is side, angle, side. We do not know an angle with the side across from it. I don't know little b even though I know angle B. Okay, now in a side, angle, side situation, we need to make sure that you follow through on the right steps. So if it's side, angle, side, you want to use the law of cosines. Okay, in a side, angle, side situation, the first thing that I want to do, is I want to find the third side. Okay, in this case, my third side is what? B. Little b, absolutely. Which means that by law of cosines, because I have to use law of cosines to find that third side. So we have little b squared equal to my other two sides squared, so that's going to be a squared plus c squared, subtract 2 multiplied by my other two sides, a times c, times the cosine of the angle that matches the little side on this side, which is the cosine of angle B. Okay, so little b squared, I don't know him, is equal to little a, which is 22 squared, plus little c, which is 19 squared, subtract 2 times little a, which is 22, times little c, which is 19, times the cosine of my angle B, which is 81. All right, very quickly get out your calculators. And this really, honestly, making sure, calculator needs to be in degrees, but this is one set of keystrokes. There shouldn't be any enters even hit here. 22 squared plus 19 squared minus 2 times 22 times 19 times the cosine of 81. This should be one set of keystrokes, and then we hit enter. All right, now what do we get for that? Does somebody have that? What do we get for that? Yep, Andy? Perfect, love it. Now, 714.22 is equal to b squared. So what do I do to get b? I'm going to square root both sides. Okay, so b is approximately equal to what? Now I realize when I square root both sides I have to do plus or minus, but obviously I'm only going to take the positive one because I'm talking about a side. Mr. Kraft.
26.72.
About 26.72. Fair enough? All right, so little b is about 26.72. Now, the next thing that I'm going to do is I'm going to set up the law of sines. Okay? Law of sines is a lot easier to work with than law of cosines. This is a lot bigger, uglier formula. So the next thing I'm going to do is set up the law of sines. Okay? Now, when I set up that law of sines, we should notice, okay, we have the sine of angle A, I don't know him, over little a, 22, is equal to the sine of angle B, which is 81, over little b, which is 26.72, is equal to the sine of angle C over little c, which is 19. Okay, now, obviously things are good here because I have one full fraction that is now complete, so I know that law of sines is great. But we need to be very, very careful here, okay? We need to make sure, because we know that the sign of supplements is the same, correct? We want to avoid being in a situation where we might have more than one possibility for the sign of our angle. Does that make sense? So, in order to alleviate that, we will find the next smallest angle next. The second thing you want to do is you want to find the smallest angle you do not know. Now in this situation, what is the smallest angle that we don't know in this situation yet? C. C is actually the smallest angle in the whole triangle, right? Because it's opposite of the side that's 19. So that means that I'm going to find angle C first. So we have the sine of 81 over 26.72 equal to the sine of angle C over 19. All right, what do I do to solve that situation? And cross multiply. So 19 times the sine of 81 is equal to 26.72 times the sine of C. All right, Logan, what do I do to start getting that angle C?
Multiply 19 by sine of 81.
Uh-huh, and then what?
Divide by 26.72.
Beautiful. I'm going to divide both sides by 26.72. So as Logan said, 19 times the sine of 81 divided by 26.72. What do we get approximately for that? What do we get approximately for that? 0.7. I got about 0.7028, if that seems reasonable. 2.3. Okay. All right. Now, that's equal to what, though? That's equal to the sine of angle C. So how do I actually find angle C? Inverse sine. All right. So the measure of angle C is approximately how much? How much do we get when we take the inverse sine of that value in your calculator? 44 point what? 61. Do we agree with that?
Yep.
All right. So angle C is about 44.61 degrees. Okay, so what do I need to do next? What do I need to do next? You bet. Last but not least, I need to find the third angle. And in this case, that third angle is angle A. How do I find angle A? Beautiful. 180, subtract the two angles I already know, which are 81 and 44.61. So measure of angle A is approximately equal to how much? Somebody have that? What do we get for angle A? 54.39 degrees. So angle A is 54.39 degrees. I've solved the triangle. I know all of the sides and all of the angles. Any questions? You've done law of cosines before. Law of cosines is a beautiful thing because law of cosines works all of the time. But the formula is a lot nastier than using law of sines. So we try to use law of sines whenever possible because it's simply easier to use. But if you get to a situation where you're unsure of what to use, law of sines or law of cosines, I'm going to go with law of cosines because it works in every situation. Any questions? Okay.